Alright, so we want to solve this inequality that we're given here, and we want to give the solution set. Remember, the solution set is all the numbers that solve the inequality that you can plug into it to make it a true mathematical statement. We want to give the solution set in both interval and graph form. So, solving an inequality is very similar to solving an equation. There is one little small tweak, change, but other than that, if it's a linear inequality, your goal is to get all the x's together, isolate the x, and you'll have the solution. But before we can do that, we need to do any distribution that is necessary. For instance, this minus right here needs to be distributed through. So we'll start there. So negative 9 minus x minus 5 greater than or equal to, and we can also distribute this 4 through. So 4 minus 4x. Alright. This right-hand side, right here, is good to go. We cannot simplify that any further. So what we'll do is we can simplify this left-hand side and by combining the constants. So a negative 9 minus 5 is a negative 14 minus x is greater than or equal to 4 minus 4x. Okay, so at this point we want to get all the x's to one side. So basically what we're going to try to do is let's move this x right here over to this side. And so to do that, we're going to, like we've always done, we're going to add 4x to both sides. And when we do that, we're going to end up with negative 14 still. But now we'll have a plus 3x here, greater than or equal to 4, and the 4x's are gone. So the x's are all together. We now want to move our constant term to the other side. So we can do that by adding 14 to both sides. And once we do that, we end up with 3x is greater than or equal to 10. Okay, and so we can now solve for x, and so we'll divide by 3. Now it's at this point when you end up dividing by a number that you have to be careful. If you ever divide by a negative, so divide or multiply by a negative. Okay, we did not do that here, but if we were dividing by negative 3, if you ever divide or multiply by a negative, so you want to switch the direction of the inequality. Let's try to spell that correctly. Alright, so our solution is then all of the numbers that are bigger than or equal to 10. Alright, so let's take that and just make it a little smaller. And so the problem says give the solution set in interval and graph form. So what we've got right here, it's now being presented in what we call inequality notation right here. Okay, so we want to present it in interval notation. So interval notation, I'm going to get to interval notation by first putting it in graph form. I think it's a nice way to do it. So putting it in graph form means you're going to put it on a number line, right? So there's your number line, and normally you could label that number line with all of your numbers. We're going to only need one number, and that's 10. So we're going to say 10 is there, and we know because we know what the solution is all numbers bigger than 10, that we're going to shade here to the right of 10. And at 10 itself, we include 10 because it's a greater than or equal to, so we're going to put a square bracket. So that's the graph form. Okay. Now, it's easy to go from graph form to interval form because you look at the part you've shaded, and you basically describe its boundaries. So this shaded thing, the left boundary of it, the lowest side is 10, and the upper side is this arrow, which if you want to, think of it, you can think of that as, we know that arrow means things go on to infinity forever, so that means we can think of it as being labeled within infinity. So the low point of our shaded region is 10, so we've shaded everything from 10 all the way up to infinity, and we always put it, with the smaller number left and the bigger number right. And at 10 itself, we are including it, so we're going to put a square bracket there. But for infinity, we don't include it, and we never include infinity or positive infinity. And so this is interval form right here.